We were solving these quadratic equations by factoring, and we have to make sure that they are set equal to 0. And then we find our factors, and when we have set those equal to 0, we solve for that x. Okay? Solve for that x. Now, we did this part A for this equation. Now we're going to follow up with part B because we can actually sketch a graph from this. Okay? So part B says use those roots of the equation x squared minus 2x minus 8 equals 0 to sketch the graph of the related function. All right. So our x-intercepts are as they presented above when we said x equals -2 and x equals 4. So our x-intercepts are at -2, and remember, we don't want to write it as an ordered pair. We don't want a comma there. -2 and 4. That's the x-intercepts. That's where our graph is going to cross the x-axis. So at -2, which I'm going to take every box to be 1 unit, there's -2 and 1, 2, 3, 4, because I know my x-intercepts are on the x-axis. Okay? The axis of symmetry. Axis of symmetry. Now, there's a couple ways you can do this. We know what that formula is, don't we? Just say yes. Yes. Do we remember what that formula is? Axis of symmetry. It is x equals opposite of b divided by 2a. X equals opposite of b divided by 2a. So when we have, you can barely see it, maybe I need to erase some of this, and maybe some of this. When we have this equation right here, my a, I'm going to write them down. A is equal to 1, b is equal to -2, and c is equal to -8. Would you agree? Okay, so the opposite of b is going to be +2 divided by 2 times my a value of 1, which gives me 2 over 2. So x is equal to 1. X is equal to 1. Now, we did that, but take a look at these 2 points. Okay? We know if this is a parabola and this is where it is crossing the x-axis, it's going to be symmetric, right? So if I have 1, 2, 3, 4, 5, 6 spaces and you count 3 in towards the middle, you will still get a equals 1. Does everybody kind of see that? It's like, duh, it's in the middle. Okay? But here is our axis of symmetry. Remember, that is the middle of this parabola. All right. And what else do we know? Y-intercept. Now, you would have to go to maybe the first page when we were just starting to talk about general standard form, factored form, and all of those. And we said general standard form, the thing that it's good for is to tell us where the y-intercept is. Does anybody happen to remember what that is? Go back, maybe flip back in your notes. Take a look. Does anybody ever look at their notes a second time after you take them? You really should. Everybody, flip back, first couple pages. I think it's like the first page. And look for the general or standard form. It gives you the y-intercept. Gives you the y-intercept. Everybody see? I mean, it's like the first page, I think. Maybe. I guess I could flip back. That's a lot of flipping. Oh, shoot. Is that in this one? No, sorry. It was in 12A. I think it was in 12A. Duh. Okay. So maybe not this chapter. So it was the beginning of the last chapter. Time flies when you're having fun. All right. So the y-intercept is the c value. So the y-intercept here is going to be -8. And let's put down here, it's the c value when you are in standard or general form. Okay? So that means my y-intercept is -8. That means it's on the y-axis, not on the axis of symmetry. So I go 1, 2, 3, 4, 5, 6, 7, 8. That is my y-intercept, which means, where am I going to find my vertex, you think? Is it going to be above that or below that? No. Well, let's do this last one. Because A is positive, the graph is going to open in what direction? Open up or open downward? Up. Now, if you are looking at this and you have these 2 points, so we know this is going to be going up, right? Because we just said it's opening up. This would have to come down here, which means my vertex is probably going to be maybe at least 1 unit lower. And we could actually find the vertex by knowing that here's our axis of symmetry. So our vertex would lie on that point. And if I did f of 1 with that x squared minus 2x minus 8, we could find that. But they're not asking for it, and we already have a general drawing for our graph, so we're not going to do that. Okay? Questions on how we came up with that graph? So what you have to know is when you solve for those x values at the very end, when we set that equation equal to 0, those are your x-intercepts. That is where the graph crosses the x-axis. Okay? All right, let me see what else we have here. All right, we could do the check, but this has when a is equal to 1, which isn't terribly difficult, and it's got it when we set it equal to 0. So let's turn the page. And now let's take a look at this first problem at the top of page 9. So this is page 9. Page 9. Okay, so what we said, we don't even have a trinomial here. Well, we kind of do. We have a trinomial set equal to 1. Does anybody remember when we are trying to solve these quadratic equations, we have to have the equation set equal to, anyone? 0. This is not equal to 0, so we have to set it equal to 0. That means I need to move that 1. How do I move that 1? Subtract. All right, so let's subtract 1. And if you subtract 1 from one side of the equation, you have to subtract 1 from the other side. So the 1's cancel out. There we have 0. And over here, I have 2x squared minus 4x plus 6. 2x squared minus 4x plus 6. Does that make some sense? You have to set it equal to 0. So if you have a number on the other side, you're going to have to move it to the other side. Okay? Angel. All right, so now we're back to factoring, to solve by factoring. What do I need to look for first? GCF, yes, GCF. So take a look at all those values. Somebody's got their music or a podcast on, probably music. Do I have a GCF? What is it? 2. Yes, these are all even numbers. So let's divide by 2. Everything gets divided by 2. That means that 2 comes out front as my GCF. What do I have left? X squared minus 4 divided by 2 is 2x plus 3 equals 0. Okay? Now, 2 is my first factor, but we got to do some more factoring. But obviously 2 is not equal to 0. So that's not going to be one of our x-intercepts. But let's focus on this trinomial. When you have a trinomial, you've already checked for GCF. What do you look for next? Or how would I factor this? Say it again. Distributive? Sort of. I think they might have called it that, but it's actually the X box, right? When you have 3 terms, you got to do X box. So let's do the X. In the top part, we have A times C. The bottom, we have B. So here's my A value, 1. Here is my B value, -2. Here's my C value. So I have 1 times C, which is 3. So 1 times 3 is 3. And the bottom is -2. So that tells me I'm going to have a negative and a positive. Actually, no. Ooh. Adds up to 2, positive 3. All right, so I need factors of 3 that multiply, and when I add them together, I get -2. Did I do everything right? Did I copy everything right? Maybe I did. Okay, so factors of 3 are just 1 and 3. They have to add to give -2. So that means this one is going to be negative. But to make that negative, this has to be, to make that a positive, this has to be -2. But then when I add them together, all right, hang on a minute. Ooh. Either I made a mistake, which is very possible, or does anybody see where I made a mistake? I don't think I made a mistake. I think this is going to be, anybody want to take a guess? No solution. No real solution. So it is not possible, okay? It is not possible to come up with 2 numbers here so that we get a positive 3 and add up to -2. And sometimes that happens. So that means this is no real solution. No real solution. If you are not able to come up with that. Now, try not to use that as a crutch, okay? You really need to try to find the answers that will work for that most of the time. But that one definitely is not possible. Questions on that? Let's see. Let's try this one next to it. How many more do I have here? Difference of squares. And that. All right. We'll try it. All right, let's try the one next to it. X squared plus 4x minus 40 equals 5. Can I start factoring this right away? Survey says no. Why not? Not just because of that. I need to have it set equal to 0. Yes, I need to have it set equal to 0. So what would I do to make that equal to 0, class? Anybody? Yeah, subtract the 5. So subtract 5. Subtract 5. 5s cancel out. Now I have 0. Oh, yeah, I feel much better. And we have x squared plus 4x and negative 40. Take away 5 more is negative 45. All right, now we have a nice trinomial. What do I check for first? GCF. Now, this is a 1, so my numbers are not going to have a GCF. And I don't have an x in each one, so there is none. So that means with 3 terms, I need to go to X box. So A times C. A is 1. C is negative 45, so that stays as negative 45. My B value is 4. I need factors of negative 45 that are going to add to be 4. Good morning. Got a path? Thank you. What are my factors? 9 and what goes 9 times what gives me negative 45? Negative 5. So 9 plus negative 5 gives me 4 when I add, and 9 times negative 5 gives me negative 45 when I add. Guess what? A is equal to 1. We like that. So we set our 2 variables or 2 sets of parentheses here. I put an x in front, or whatever your variable is up front. And then you write these values exactly as they are. So this is x minus 5 and x plus 9 equals 0. So I set this up in my table. You don't have to do the table, but you can. If x minus 5 is equal to 0, and you do the little algebra, obviously x has to be equal to 5. And if x plus 9 is equal to 0, you can probably tell again already, subtract 9, x is equal to negative 9. So here are my 2 roots, my x-intercepts. These are the x-intercepts, okay, which means they are both 2 real solutions. That one was much nicer. Questions on that? Is this making some sense? That's what I'm looking for. Yes, no. Just simple head nod. Yes or no. Yes, making some sense? Okay. All right. Are you ready to take it another step further? We always keep pushing the boundaries in math, don't we? All right. Let's take a look at the bottom of the page. This is the bottom of page 9. Solve a quadratic equation by factoring a difference of squares. Oh, we can do that. All right. First of all, we need to check. Is it set equal to 0? Check. Yes. All right. Then when we are solving by factoring, what do I need to check for first? What type of factoring do I always check for first? GCF. So put it over here. GCF. Do I have one? Well, let's see. This is a 1 in front, so not going to be for the numbers. I won't have a GCF. Do I have an X in every term? No, so I don't have a GCF. Now I have 2 terms. 2 terms. And there's a subtraction in between them. So this looks like it is possibly going to be a difference of two squares? Well, the first one is definitely squared already. So I'm going to say x squared minus, how could I rewrite this as something squared? What number squared gives me 16? 4. Yes. So x squared minus 4 squared equals 0. And this one, you really pretty much have to know and memorize this little trick. I don't like the word trick, but you have to memorize it. Those are your two values, like a squared minus b squared. So when you set up your two sets of factors, you put this first value, x, and you say plus 4, and the other one is going to be x minus 4 equals 0. So some of you are like, wait, where does she get that? That's that a squared minus b squared, and it is a plus b times a minus b. That's where we got that. Okay, so we could set up our little table. It's kind of like setting the table. So this side, x plus 4 equals 0. Subtract 4, subtract 4. X is equal to negative 4. And on the other side, x minus 4 equals 0. Add 4, add 4. So x is equal to positive 4. There you go. X equals negative 4 and x equals positive 4. Questions on that? Let's see. Trying to watch my time. Ooh. What is that? 11? Okay. Let's go back. Actually, you're right there. Let's try. Do you want to try the next one? Yeah, we'll try the next one. 4x squared minus 49 equals 0. First of all, I need to check. Is it set equal to 0? Survey says, yeah. All right. Then what do I check for first? When I'm factoring to solve these, need to check for GCF. Ooh, we got a number out in front. Always start with your smallest number. 4. Is 4 a factor of 49? 4 a factor of 49. Can I take 49 divided by 4 and get a whole number? No. What is my next highest factor of 4? 2. Is 2 a factor of 49? No. And then there's 1, but 1's not helpful. So we do not have a GCF. I have 2 terms with a subtraction in between. So we are going to try difference of 2 squares. Okay. Now we got the x squared here. So I need to come up and say, okay, what number squared or to the second power gives me 4? 2, right? So that is 2 squared x squared minus what number squared gives me 49? 7. Now, we're going to rewrite this a little bit because the law of exponents says if you have 2 numbers that are multiplied together and they're both squared, then you can combine those and put the 2 on the outside. Because then we used to say you would distribute. This is 2 squared and x squared. We were doing that in reverse. Minus, now that's a 7 squared. Some of you go like that. Okay. And now here are my A term and my B term. So I set this up as quantity 2x plus 7 times 2x minus 7 equals 0. 2x plus 7 and 2x minus 7. Now, some of you I know might like to put the minus first and say 2x minus 7 times 2x plus 7. Doesn't matter. Either way. Okay? So then we can set up our little table and say 2x plus 7 equals 0. 2x minus 7 equals 0. And we have to do a little bit more algebraic work here. We want to solve for x, so we leave that to the end. So subtract 7. 7 cancels out. 2x equals negative 7. Divide by 2, divide by 2. X is equal to negative 7 halves. And just leave it like that. We do not need to change it to a decimal. I know you guys love changing that stuff to decimals, but it's okay. And over here, let's add 7 to get the x by itself. We got 2x equals positive 7. Divide by 2, divide by 2. X is equal to 7 halves. Now, in case you're wondering, 6 halves would be 3, right? 8 halves is going to be 4. So that means if you're talking about 7 halves, you're talking about 3.5. Just so you know. So this is basically negative 3.5 and positive 3.5. Okay? Negative 3.5 and positive 3.5. And those are your x-intercepts. Okay, is this making some sense? It's not that bad, right? We just keep adding on extra little steps, okay? Any questions about this? Do you like the difference of two squares factoring? That's my favorite kind of factoring. A plus b, a minus b. It's all for x. All right, let's turn the page. You guys are doing great. Fantastic. Fan-flippin-tastic. You're doing great. All right. So now we're going to write functions given the zeros. Remember, the zeros is just another word for your x-intercepts. So when they give us the x-intercept, can we write the function? And we can. Remember, zeros is just x-intercepts. You can write the equation of a quadratic function if you know its zeros. First, find the factors of a related expression. 2, determine whether the value of a is positive or negative. And assume, and this comes a lot of the time, assume a is 1 or negative 1/2. Because that a value can change from the graph, and you can't always tell, is that an a is 1, a is 1/2, what is that? So let's take a look. Example 8, write a quadratic function given the graph. Roots, x-intercepts. I want you to circle the roots right now on this paper. Circle the roots by looking at that graph. 3, 2, and 1. Hopefully you circled -2 and 6 because that is where the graph crossed the x-axis. So our roots are -2 and 6. Remember, no commas. No commas. The a value, is it +1 or -1? I want you to circle that. What do you think the a value is? Take a look at the graph. Which way is it opening? Circle your answer, and 3, 2, 1. Hopefully you circled +1 because it is opening upward. So the factored form, I want you to write the general standard form. It is factored form, but it followed this. Y is equal to A times x minus root sub 1 and x minus root sub 2. That is what we're looking for. And we have all of those things. So we are going to rewrite that up here now as y equals, we said A was positive 1, so we're just substituting in, times x minus, now our first root is negative 2. You cannot have and subtract a negative. So we need to change that to a positive 2. So everybody see that? It's kind of like opposite when you are writing down these roots. Demarian's like, oh no. And for the other one, second set of parentheses, x. So the x's are always going to remain as x's. It's the roots that change, okay? And here, my root is 6, so it is x minus 6. And that is your factored form. Now think about it. Think about it in this way. If you're like, I have to subtract root minus x plus 2, x has to be negative 2. Think about if you substitute that in, you want to get 0. X minus 6 would have to be 6 minus 6. So that's a way to check because you are always going to have to set those equal to 0. Does that kind of make some sense? But just remember, it's x minus the root. So if it's a positive root, it stays as it is. And if it's a negative root, you can't subtract a negative. So that's why you have to add the opposite. Okay? All right. Let's go to the top of the next page. Write a quadratic function in factored form for the following graphs. All right. First of all, roots, x-intercepts. Make it obvious to your eyes. You should be circling the 2 and the 4. The a value. What is my a value? Lennon, is it 1 or negative 1? Is it opening up? Yeah, it's positive 1. So my factored form, remember, this is y equals a times x minus root 1, x minus root 2. So I'm going to say y equals positive 1 times x minus, well, that's just a positive root. So x minus 2 and x minus 4. So the positive 1 comes here, the root comes here, and the root comes here. That's not so bad, right? All right, let's look at the last one of this type. Roots, x-intercepts, circle it. Make sure you are circling where the graph crosses the x-axis. So that is negative 2 and 6. A value, positive 1/2 or negative 1/2. Oh my gosh, this is not 1 or negative 1. Yes, but it's still a positive versus a negative. We're only giving you 2 choices. So since it is opening downward, it must be excellent. It must be negative because it's opening downward. Does everybody see what I'm saying when I say it's opening downward? Right? I'm talking about here. We're going down. So my factored form, y equals a times x minus root 1, x minus root 2, is y equals, now don't forget, it's not 1 and negative 1, it's negative 1/2 times x minus, all right, your root 1 is -2. We can't have subtracting a -2, so that's why we say change it to a +2, right? And x minus 6. That's getting really close to the edge there. So the 1/2 came from here. The -2 was here, but you can't subtract -2, so it became +2, and x minus 6. Questions on that? All right. Now let's go in reverse. Now they are giving us the factored form, and we need to sketch a graph. Okay? So what are my roots here as I look at letter A? Well, let's see. I know the roots were x minus root 1 and x minus root 2. So the root here, x minus, that means my root is 4, but this does not say x minus. So this would be x minus -3, right? And that's why they changed it to +3. So that means this is -3. Is everybody with me on that? All right. And is this going to open up or down? Well, what is my A value here? There's nothing there, Miss Thede. You're right. So that is a 1, understood. That is a +1, which means it is going to open up. So my roots are at 4, +4. So that's 1, 2, 3, 4, and -3. 1, 2, 3. It is going to open up. Let's see. 1, 2, 3. So basically, it looks like, and we don't really know anything else, but we know the axis of symmetry would kind of be somewhere here in the middle. So we just need to go like this. We don't know where the vertex is. We're just doing a general graph. Going through the roots and opening up. That's all we need. Okay? Questions on that? All we need are the roots and opens up. Opens up. All right, let's take a look at B. Y equals negative, parentheses, x plus 2 times quantity x plus 4. My roots have to be in the minus. So this is minus -2. That means that is a -2, and x minus -4. So then it's -2 and -4. And because this is negative, that's my A value. A is -1. That means it is opening down. So my roots are at -2, 1, 2, and -4, right there. It is a negative value. It's opening down. And A is just 1, so it's going to be like really pretty close there. There it is. Questions on that? And let's see what else we can do. Any questions on that? We have covered a lot of stuff. I think it makes most sense, or it seems to have made most sense. Oh yeah, we're not going into that. So tomorrow we get into these things that are called imaginary numbers. So when you don't have a real root, it could be imaginary or part of a square root. All right, so here's what we know. Homework 1 was due a while ago. Homework 2 is due tomorrow. I believe I said that on Friday. So let's make sure you get homework number 2 done for tomorrow. Okay? Look over your notes. That's why we take the notes. That's why you can refer back to them. So use your notes while you are doing your homework. Okay?